Hello, good morning, everybody. It is my pleasure to introduce Mr. Ritesh Paiboina, who is working for ITSH as a cloud architect. My name is Martin Loschwitz. I am a waste management consultant, and in my free time, I also work as a public cloud architect for T-Systems. Before I get into this, I would like to ask you one question. Who of you has ever called some sort of service provider because some infrastructure was not working the way it was supposed to be working? So your internet didn't work at home or public transport didn't work. Who has ever called a hotline and complained? Okay, and who has ever called a hotline and thanked the company for providing such a great service that actually did work at the time when you were calling them? One person, that's very lovely of you. For all the rest, shame on you. Obviously, for those who did not do that, there's a very good explanation. As we all know, we have an IT background here in this round, and we are infrastructure people. So we know that we want to have a system that basically works all the time, and if that is the case, then we are mostly invisible to our customers. Nevertheless, hardware breaks, software breaks, basically, at any time and point, something may go wrong, and we are only good at our role as a service provider if we manage to identify issues before the customer does. Nevertheless, nobody actually ever I spoke to liked dealing with monitoring. And the thing is, we cannot do without it. We cannot really do without monitoring because we want to know in time when things go wrong. And some customers actually may believe that what we do in case something goes wrong is this, and that is obviously not true, but then what are we actually doing? What are we doing to detect problems in our data centers and in the context of a cloud, of a setup like the Open Telekom Cloud? Fact is, we cannot work without monitoring. That's just not possible. And what's the reason for the fact that so many people do not like working with conventional monitoring systems like Nagios, Itzinga, and all these things? There's a number of reasons for that case. Reason number one is the fact that most of these systems are actually event-driven. So what they're very good at is finding out what is the status of my service right now, which means that if my server bursts into flames, then Nagios is a very good tool to notice that and to figure that out, but actually it's only that. What I cannot do with Nagios or any of the other tools properly is finding out what the tendency of the quality of a service actually is. So conventional tools work well to determine outages and problems as early as possible. Conventional monitoring systems also are a large, monolithic, and complex construct. Typically, everybody in the room who has ever dealt with Nagios knows what I'm talking about. It's basically an utterly large beast, and even if you have only setups of small sizes, then getting them up and running is tedious, and maintaining them properly is tedious as well. One of the reasons for that is that typically they use static configuration files, or they get a configuration information from some kind of semi-dynamic database, which means there is a list somewhere that basically contains the number of nodes, and the monitoring system then uses that. Now, the thing is, if we can do that with conventional monitoring systems, if they work so well for small conventional setups, then why did we just not go with Nagios or Itzinga or anything the like for the Open Telekom Cloud? And one of the reasons for that, obviously the first and most obvious one, is the fact that the Open Telekom Cloud is not a small setup. So at this time, we're talking about several thousand hosts, and the setup is expected to increase in size dramatically. What, however, is even more important is the fact that the Open Telekom Cloud is a cloud. So it's actually a setup that is built for seamless scale-out at any time. And in large setups that are built for seamless scale-out, we are not only having an issue with the monitoring of events, what is happening in my cloud right now, but we also need another dimension of monitoring, and that dimension is trending. Trending does not actually have anything to do with the status of my service at a specific point in time. Instead, trending helps cloud providers to better predict the need for actual hardware in the data center. What you typically do as a cloud service provider is You run a setup with a certain buffer of resources so that at some point in time, new customers can sign up and just get the resources that they expect. But you will want to know when that buffer becomes smaller so that you can actually order new hardware. Ordering new hardware takes some time. In fact, people believe that serverless is good because they don't need servers anymore, but we are the company actually running the servers that customers need to go serverless. And if you need to get new hardware, that's going to take a while. And we need to build it in, we need to install it, so we need to know as early as possible. And in clouds, at any time, this can happen. Any customer at any time can basically just decide, I need another 500 virtual machines, and I need them right now. And that is why we need to have a very good understanding of what the resource usage in our platform actually is developing like. Which means that unfortunately, we cannot do without a certain form of training either. And now that you think of it, if you have a monitoring system that regularly connects to the machines anyway to figure out what the status of a specific service is, then we could actually just use the same functionality to have that check also get the resource usage information that we are so desperately looking for. And that is why at some point, the idea is, why do we not let our monitoring system just collect the metric data that we need for trending? And the standard approach for this are tools like Plug and Play for Nagios or Plug and Play for Isinga. Certain monitoring solutions have their metric collection integrated, such as Zabbix. And all these systems store their data in some sort of database, a standard database like MySQL, PostgreSQL. Now, this is actually a bit of an issue in our case, and in the case of any large cloud environment. Think of this, we need trending data in intervals as little as 15 seconds or even less. Now, if we assume that we are collecting 200 metrics per host with the total number of hosts of 3,500, that means 2.8 million of metric values per minute. And it doesn't get better when the cloud scales. At some point, you will find yourself in a situation in which you're easily writing millions and millions and millions of entries into your database in a minute. And this is already a challenge for databases. Everybody who has ever tried to tune a MySQL to do that will certainly know this. But the problem does not actually stop here. In any standard database, metrics will be stored as individual entries. So I have databases, I have tables, and I have rows in these databases. What is very easy to do if my data are stored like this is a query like this. How much traffic did Apache generate at a specific point in time on a certain date? That's just one line that actually needs to be read from the database, and that is the answer that I want. But for trending, my actual reading of the data is different, because what I need for meaningful trending is a stream of events. So what I want to know is how much traffic did Apache generate between July the 17th and today. And if I want to do that with a standard database, then what's actually happening is that the database will fetch all the records matching a set pattern from the database that it has, and then compile them into a result. And if I do that with databases that have hundreds of millions of entries, because I'm writing 10 millions a minute into the tables, this is very tedious. This takes ages, and it may even completely outperform the database. Anybody who has ever tried to get metric data using Plug and Play for Nagios over a large time frame will have noticed that that was very slow, and that may well have been because the database just didn't cut with the load anymore. So this is not a solution that we can do. For meaningful trending, we cannot actually store data like a normal database would do. Let's face it, we need another way of storing data for meaningful trending in the cloud. And this is where time series come in. Time series solve exactly the problem that I have just described. They allow to store data on a timeline just as they flow in. So the basic element, the root element of a time series database are not actually tables and rows, but instead it's a timeline that incoming values are attached to. The implicit storage format of a time series database, hence, is exactly the format that we need if we want to generate metric information over specific periods of time. And the cool thing is, now we're coming back to the monitoring topic, if it's easy for us to get specific information over a certain period of time, then actually we could also do monitoring using exactly the same technology. Because in fact, in time series databases, anything can be a metric. So what I can have as a metric is the number of Apache processes running on the system, or the number of overall available Nova API instances in my setup. And if I take this, what is the fill state of my file systems on all hosts, then that is also just something that I can express as a metric in a time series database. So in fact, event-based monitoring can be a side effect of trending. Because in fact, what event-based monitoring is nothing but a stream, but a time stream with the smallest possible amount of time, and that is one specific point in time. So what I need to do is I need to configure my time series database so that if a metric X on host Y exceeds a certain threshold, trigger an alarm. If I can do that, then I can easily do monitoring using my time series database, and I will still have the same data for trending in exactly the same system. And this is where Prometheus comes in. Who of you has worked with Prometheus in the past? Okay, some people at all. This is the logo, so if you ever want to look into Prometheus, that is what you need to watch out for. What's important to understand about Prometheus is that it was originally developed by SoundCloud, but it's now backed by a large community. There have been some rumors in the past about SoundCloud maybe going bankrupt. Prometheus by now has a very vivid open source community backing it. So in fact, even if SoundCloud was to disappear, that would not actually harm the development and the functionality of Prometheus. It's licensed under the Apache license. It's completely free and open source software. Everybody can use it. Everybody can get the source. Everybody can modify the source if seen fit. And in fact, Prometheus is a high-performance, small footprint time series database capable of doing exactly the things that I have explained earlier. What's interesting to note about Prometheus is that Prometheus works based on the pulp principle. So in fact, Prometheus will fetch data from monitoring targets. That is what in Prometheus speak they call scrape. It's not that the individual clients send the results of their monitoring to Prometheus servers, but the Prometheus server in this case is responsible for fetching that information from these servers in place. Data and monitoring targets are locally collected by agents. In Prometheus speak, these are called exporters. And they are made available to Prometheus so that Prometheus can actually just trigger them, just scrape them using a standardized API format based on the API URL of the agent of the exporter on every single node. I can run multiple exporters on a single host, providing different individual metrics that I need to have in my Prometheus instance. And in fact, this setup is very flexible, and it allows for a very widespread use of different metric data on individual hosts. Now, the important thing we earlier mentioned is that we need alarms if we want our time series database for trending also to be usable for monitoring. And that is why in Prometheus, you have the Prometheus Alert Manager. This is the place where you determine, where you define what the rules are for firing alarms based on the actual values that Prometheus scrapes from the exporters on the target nodes. And this is an architectural overview of Prometheus. I'm not a big fan of showing architectural overviews without explaining them, so I'll just give you a quick run through this. The central part, as you can see, is the Prometheus server. The Prometheus server itself is the actual time series database that is responsible for collecting the metric information from the target hosts, but it's also responsible for storing them on a local disk. Last but not least, Prometheus has an API that you can use to actually arbitrarily query data from the metrics database that you have. They invented a separate scripting language for this, or a separate query language actually, that is called PromQL. It looks a bit like SQL, and if you have some experience in using SQL, then you will likely not have any issues using it. It's still not the same though. So you will need to consult the documentation from time to time, but the documentation on PromQL is actually very helpful, so that should not be an issue. We have the exporters on your left. Those are the ones collecting metric information on the target hosts. We have the alert manager on your right, top right corner of the picture. The alert manager is the tool that will basically fetch the metric data and then issue alerts based on what it sees inside this metric data. And last but not least, there is the push gateway on the top left corner of your picture. The push gateway is made for services that cannot actually run exporters for Prometheus. So think of tools such as network devices using SNMP. These can actually make their data available. They can send it to the push gateway, and then Prometheus can just scrape these information from the push gateway just like it would do from any other normal exporter that it connects to in a network. And last but not least, on the lower right corner of the picture, we can see the web interfaces. Prometheus used to have a separate web interface. That is not the case anymore. These days they use Grafana, and I will show you some pictures about Grafana in a few minutes from now. Now, one of the cool things about Prometheus is that because it's thoroughly using open APIs and open standards, it can actually seamlessly be combined with other solutions. And one of these examples for that is Graphite. This was one of the funniest moments throughout the whole Prometheus project, which we did at the Open Telekom Cloud. We had originally intended Prometheus to be used for all sorts of trending, so short-term trending, mid-term trending, long-term trending, and monitoring. And then at some point, we realized that Prometheus is not doing particularly well if it has to store large amounts of long-term trending and metric data. So we needed to find something that would work better in the context of a platform with several thousand hosts that is actually still growing. And the good news was that Graphite is actually very good at that. So what we decided to do is we decided to downsample data from Prometheus into Graphite. That works very well because Prometheus comes with a separate adapter for Graphite. You can just instruct Prometheus to relay certain kinds of data to Graphite, and it will just do that with no hassle and without any additional software being required. Another great example where you combine Prometheus with other tools is the Prometheus standard node exporter. This one collects metric information such as hard disks, file system statuses, uptime, CPU load, and so further. And some of the features that the Prometheus standard node exporter actually has are not very good when it comes to a few particular metric data. Basically, it does not record all the metric data that you want, and that is where at some point you can just simply switch to another solution, and that is Telegraph from the TIC stack. TIC is the InfluxDB stack, and because Telegraph has a native API that Prometheus can just trigger, you can very easily use TIC, or actually the Telegraph agent on the nodes, to have Prometheus scrape data from there. You're basically combining a number of tools from different stacks to get the best out of all of them, and that is very helpful. As already explained, Prometheus has an open and generic API. That is very helpful because it allows for a number of other external interfaces to be used. Grafana, Alerta, and ANSI are three examples for this. Grafana, everybody, I guess, who has seen Grafana already? Yeah, that's the majority, I guess that. Grafana is cool when it comes to visualizing any kind of data that you may have. It's the de facto open source standard by now. And Grafana has native support for Prometheus built in. So you basically just count Grafana to the Prometheus server that you are running, and then you are basically just set up for this. And you can basically just have the images generated in Grafana based on certain Prometheus queries that you implement in your Grafana dashboard. You can do this for arbitrary kinds of information. This one example here is a basic example for an Apache server. You can, of course, also display basic node information in Grafana. You can use things like the memory that is in use, the CPUs that are in use. You can use the cluster file system, if you have one, to be displayed in Grafana. The opportunities that you have to visualize data in Grafana are practically unlimited. And the cool thing about Grafana, in fact, is that hundreds of predefined dashboards for Grafana are publicly available already. So it's not like you need to start from scratch. You can base your work on what others have already created and made available to the internet. So that is very helpful. Alerta is an addition to the Prometheus Alert Manager. The alerter web interface basically adds a function that the alert manager, the native alert manager in Prometheus doesn't have just yet, and that is the ability to display a nice status dashboard of what you have as alerts in your Prometheus installation at this time. I guess everybody who has been in operations knows this. You have a certain central screen in the office that displays all the current alerts. And that is basically what Alerter adds to the Prometheus Alert Manager, because the Prometheus Alert Manager has a separate graphical user interface, but it's not that beautiful. With Alerter, you can just do that. And the cool thing about Alerter is that from within Alerter, you can even manipulate the things that you have in Prometheus. ANSI is an alternative to that. If you're more of a dashboard kind of person, then you can use ANSI, which also talks to the Alert Manager in the background. And does the same thing, but with different optics. Seamless integration with tools such as PagerDuty, OpsGenie, and others is present in Prometheus, so you can combine the Prometheus Alert Manager with any of these mentioned services. They all provide API endpoints for the Prometheus Alert Manager to talk to. And if you have other pre-existing monitoring setups, that's also one cool thing that Prometheus actually offers. We had one such case, because in the Open Telekom Cloud, we have a Zabbix setup that was actually part of Fusion Sphere, and that collects certain kind of metrics that we did not want to create exporters for, because that would have been tedious. So what we actually do is we just get the required alarms out of Zabbix and place them into Prometheus. We combine the existing solution with the new one, and that works like a charm. We basically get the error messages that we need in our Prometheus. They are part of the standard alarming. They are part of the paging. That is a very convenient way to not have to rewrite a number of arbitrary checks. Now, getting the Prometheus architecture right is challenging because scalability is an issue. In contrast to what most people would expect, Prometheus does not actually have some sort of cluster mode. You cannot just combine dozens of Prometheus instances and then make sure that they will automatically have all the same and valid set of data. And still, the good news is that we can actually run multiple Prometheus instances all behind the same front ends. So what we do is we have one alert manager, we have one alerter instance in this case, and they're all basically accessing a certain set of Prometheus instances in the background, which means that we still have a single point of administration, but we can basically have as many Prometheus setups as we want in this setup. Now, how do you actually roll this out in a setup as large as the Open Telekom Cloud? Obviously, what we need to do is we need to have Ansible to automate the rollout of the exporters on the target nodes. But how do we know what these target nodes really are? I mean, there are several thousand hosts, and somehow we need to make sure that we are rolling out the required exporters on all of them. And this actually turned out to be a challenge, and that is the reason why Ritesh is here, because he implemented this. So, the stage is yours.
Thank you, Martin. So we have a large setup of thousands of hosts. So what we do is that we use Ansible to deploy our Prometheus exporters and Prometheus server. So how do we configure everything automatically? So while we need the data for the Prometheus to scrap the target for the monitoring. So we cannot do obviously with a static configuration for more than 4,000 nodes. So we need a better solution. So we thought of using console or DNS or Kubernetes. For example, console is a service discovery mechanism which tries to do a discovery for the services and try to configure your services in your infrastructure. But what the idea was for the Prometheus the idea was for Prometheus to scrap the data automatically, either by using console, DNS services, or anything. But console was not ready for our operational use. So what we thought that we should get a more of a single source of truths where we can define more configurations. So we found one more tool called Netbox. Netbox is an open source tool originally designed by Ocean Digital. So Netbox is designed to replicate the real world scenario of the data center. So basically in Netbox you can feed any number of nodes, all the interfaces to it and all the IP address. So basically Netbox tries to help you and manage your data center, asset management, IP address, other stuff which are related to data center. But Netbox is based on the Django application, and it has a API. So you can connect with any other languages and try to fill the data to Netbox, not only manually, but automatically also. We design a Python application, which can be installed with RPM. So we feed the data to Netbox using Python. So why do we need all this setup? Is because Prometheus need a configuration file. So we generate a configuration file for the Prometheus. Like that configuration file will include all the list of monitoring hosts and its ports, and that data we came from the Netbox. So once we have all the information, we try to give it to the Prometheus. So Prometheus has a cool feature called reload. So what happens that you don't need to restart the Prometheus servers. You just send a post request to the Prometheus, it will automatically reload it. If the configuration file has been unchanged, then it will not apply anything. But there is one more thing. Maybe Martin, you could like to say?
Thank you. I never heard somebody speaking faster than I, by the way. That's impressive. You need to tell me how to do that. Thank you, Ritesh. Yeah, there's one more thing, and that is what I would like to mention now, because obviously every good presentation these days has to mention Docker. You know, I did it without Docker in the past, and people were just sad in the end. So here we go, Docker, Docker, Docker. The funny thing about Docker is that Docker came in quite handy with regards to the new monitoring at the Open Telekom Cloud. And that is because all the components that we need, so Prometheus, the alert manager, Alerta, possibly ANSI, Graphite, answer server, and so on, all major components basically come properly prepackaged in Docker containers by their vendors. So you can just pull the actually official Docker container from the container repository for Docker, and we roll it out, and then what we need to do is we need to add our own configuration files to those. That is not an issue, because all configuration files that we have reside in Git repositories, which is the base for a complete CI/CD system. And that basically means that rolling out an individual monitoring, alerting, and trending instance with Prometheus for the Open Telekom Cloud can be done in hours. That is extremely helpful. We are just about to roll out a hybrid product, which means that for the first time, customers will actually have a combination of the Open Telekom Cloud and a setup that resembles the Open Telekom Cloud, but in their own private data center. And of course, customers will expect us to monitor that as well. So what we can do is we can basically just replicate the Prometheus setup that we have in the Open Telekom Cloud, and then it's going to be done in hours. Without any additional hassle, because as Ritesh just explained, the nodes are in Netbox anyway, the configuration will be right there, and this does not cause any additional administrational effort in this case. And with that, we have 6 minutes and 50 seconds left. Thank you everybody first, and then your questions, please. Somebody's got to have a question about this. There, please.
So, did you configure that Prometheus exporters use DNS and SSL certificates when providing the metrics, or is just plain HTTP?
Well, actually, to the best of my knowledge, the configuration that we have in this place is actually SSL backed. So Prometheus is talking to the exporters on the hosts using SSL, but there is no DNS involved in that. Why would there be DNS involved?
No, sorry, SSL/DLS, so DLS.
Yeah, it is. If the question is whether it's encrypted, yes, the traffic we have is encrypted in this case. I tried to get this through our security department without encryption. Guess what the answer was, so we had to do that. Further questions? Yes, please.
Can you compare InfluxDB and Graphite performance for starting?
Okay, so the question is whether we compared Graphite and InfluxDB. Yes, we did. We actually went with Graphite only after we had tested InfluxDB and decided it unfit for our particular needs in this case. Reasons for that were performance, basically. Graphite, in this particular case, for the downsampled long-term metric data, was particularly faster in a number of different scenarios. So yes, we did that comparison, and we decided to go with graphite in the end.
And what about resource usage?
Well, most of the machines that we have in the Open Telekom Cloud actually did not really have an impact because of the exporters that we use. So the standard node exporter or Telegraph in this case, actually Telegraph has a bit less of a footprint than the Prometheus node exporter. That's not really an issue.
I meant resource usage influx DB and graphite.
Sorry?
Resource usage when you deploy graphite and
Okay, so the question is what the resource usage of graphite and InfluxDB were. I don't remember, to be honest. The main reason for not using InfluxDB was the fact that it actually slowed down the whole setup. And that is why we decided to ditch it. Yes, please.
How many node exporters can you serve without scaling out from it?
That's a good question. So the question is how many node exporters can you scrape using one individual Prometheus instance? At this time, we are doing it around about 4,500. That is not an issue just yet. I have seen a calculation about this. I don't remember the exact numbers. It also depends on how many times in a minute you pull the node agents, obviously. I would not actually scale it down to the number of scrape targets that you have, but to the number of metrics that you try to collect in a minute. So if you have the Openstack node exporter, which we also use to gather Openstack metric information from the individual Openstack components into Prometheus, that itself is a truckload of metric data. If you pull these every 5 minutes, if you scrape these every 5 seconds, then that's a really big difference. But I know there are benchmark documents about this. So some people at least have tested this already. Does that answer your question? Thank you. Please.
Prometheus scrapes the node. Does it scrape the full status or just the update or the trend update?
So the question is whether Prometheus, when scraping a node, gets all the metric data on it or just the it will regularly pull all metric data that is present on a specific node exporter on a certain host. But once it actually has gotten the data there, the data are flushed from the node exporter, so that actually is clear. Further questions? Yes, the last one, please.
With several thousands of metrics, how do you define your errors? Do you have static thresholds or do you use some
Okay. The question is, with several thousand different kinds of metrics that we have in this setup, how do we actually define the alarms? Did I get that right? Well, with a lot of time and a lot of debugging and a lot of try and error. So this monitoring system obviously did not work perfectly from the get-go, just like no monitoring system I ever actually installed did. It's a matter of constant improvement, actually. So at some point you will notice that an alarm that you originally considered to be good actually is not good at all because it will just silently ring people out of the bed during the night for no obvious reason, and then you need to adapt that. We started with a best guess. And then started to improve the setup wherever we saw something was not working the way it should. All right, so thank you, everybody. I will just leave the stage to the next presenter, and we wish everybody a happy rest of the day. Thank you.